Hello everyone, welcome to DevConf US 2020. Hope everyone is doing well and staying safe. I'm very excited to be presenting here. I'll be presenting Kubernetes Style CI/CD system. Following would be the agenda for today's talk. We'll be going through the whole design and implementation of the CI/CD system with some knowledge about Tekton tools. And then I'll be telling you more about my challenges, the challenges which I faced, and some insights on the whole development process. Before starting, let me introduce myself. I'm Harshad Reddy Nalla. I'm a software engineer working in AI Center of Excellence, Red Hat, currently stationed in Boston. I'm a part of AI DevSecOps team. We work on a project called Thoth. It's an AI stack recommendation system. It recommends Python package modules based upon performance and security. I'm currently focusing on the AI CI. That's a Kubernetes style CI/CD, which is this whole talk based upon. I'll be talking more about it, how we designed and implemented it, and also showing a demo about that. So without any further ado, let's jump right into it. So the goal for this talk is to share my findings and learnings when I started to build this CI/CD tool with Tekton pipelines and triggers. So before going into the design and implementation, let me ask you, why do we care about the CI/CD? The CI/CD is a very integral part of the integral part of the DevOps team, or the DevOps architecture, or the DevOps lifecycle, right? When a developer or a contributor contributes to a source code, they make some new changes. They send these new changes for a review. While the reviewer's job is to review the new changes for the source code, he or she doesn't have to ensure on the syntax, styling, or linting, or any of the PyTest or checks on the testing or the end-to-end testing of this new changes. This all things could be taken care of by the continuous integration system. The reviewer can focus on reviewing the actual core code of the new changes, and once he or she feels like they are valid, they are okay to be merged, the CI system can merge that code in. Once this code gets into the source code, it needs to be delivered to the production environment or the development environment. So there the delivery part comes in. So today we'll be talking about the continuous integration delivery system. The continuous deployment, we are not considering that right now. We are just focusing on the integration and delivery aspect of it. As we wanted to build this system, we wanted something which can run on premise of Openshift, as all our core workloads runs on Openshift. So we wanted to concentrate on those aspects. While researching about it, we got to know that there's no one CI which fits all the application. The team or the maintainers have to decide on their CI/CD tool based upon their applications. So it's true that no one size fits all. As the applications are moving towards microservices from monolithical architecture, similarly, the deployment infrastructure is also moving from virtual machines to containers. As the applications are moving so fast towards the Kubernetes environment, we would like to have a CI/CD tool which is also running its workload on a containerized environment. So thus the whole focus on building a CI/CD tool with a Kubernetes style. So while doing this, while trying to develop something like this, we came across Tekton. Tekton is an open framework which allows the user or the developer to build CI/CD systems with its tool. It was created and contributed by Red Hat and Google contributors. It's now a part of CD Foundation. Before learning about Tekton, we would have to learn about Tekton terminologies. We can't just go right into the Tekton, designing and implementing a Tekton pipeline without knowing it terminologies, right? So let me take you through the journey of learning like what these terminologies are and how they are used while developing the pipeline for the CI/CD tool. So first is a step. Step is the smallest working piece of code in the pipeline. Step would be references the container image that which would execute a specific script. A task would be be running this series of steps, and a task run would be something which will initiate this initiate this whole task. For example, take building an image. So building an image would be a task. So what would be the steps involved in it? First step would be to gather all the information to build that image. Second task would be to use a Docker or a container orchestration tool such as Builder or Podman to build them. Then third task would be to publish them into a image stream registry. So this would be the following steps into a task. And if we execute this task on an onto the cloud native environment, that becomes a task run. Moving further, there is pipeline and pipeline resources. Pipeline resources is a place where you will define all the base information, such as images or Git resources. So Git resources could be anything, such as if you're describing your whole Git repository, to where to clone the repository from, or to gather the pull request information. These would be the place where you would initialize that. Pull request pipeline resources also gathers information from the output of the step of a task, and pipeline would be pipeline runs a series of tasks, and pipeline run is the initiator which will initiate the pipeline execution. So let me explain you more better with this example diagram. So if you see on your left side with the shaded blocks, those are the pipeline resources such as GitHub repository and the image. Here the image is a UPI image. A GitHub repository could be my repository. So the following other blocks are describing the task, like a code quality check, a setup environment, build image, or publish or deploy them. This whole figure describes a pipeline, and once we run this pipeline with some inputs, that becomes a pipeline run. If you see that smaller chunk of code where it's written task run, so if when the GitHub repository resources are provided to the task and the task is executed, that becomes a task run. So a pipeline constitutes of several task runs. That's how it can be defined. As we learn about the terminologies of the pipeline, let's learn some more terminologies of the Tekton trigger. A Tekton trigger takes the event payload from a webhook and provides that towards a resource applet. So what are the core components used here? There's event listener, which will be continuously listening to the HTTP request from the webhook from any of the Git environments like a GitHub or GitLab, or it can also take direct webhook payloads. So the JSON payload from this event listener is passed to the trigger binding. Trigger binding maps the content of the JSON payload to the required or to gather the required parameters. These required parameters thus are provided to the trigger template, and trigger template passes those parameters to the pipeline run. So this describes the whole concepts of basic concepts of Tekton triggers and Tekton pipelines. Using these components, we can build the whole CI/CD system. Let's jump into what design constraints or what design requirements we had, and then I'll be explaining you with all these components how we built a CI/CD tool. So as most of our projects are AI/ML oriented, we wanted to focus on them. So all the projects are Python based, so we wanted to have some static checks, unlinting checks, and styling checks. Static checks would be like PyTest, running some PyTest end-to-end test. Linting checks would be running some PyDoc styling, or some of the Flake 8 checks. Once we were done with the checks on the pull request, we also wanted to release these applications. So a Python application can be either a module, or it could be a running application. A Python module has to be released to PyPI, and then you can use it as a package. If it's an application, you can containerize them and then deploy it into an OpenShift environment. So we wanted a CI/CD system which can enable us to do some code checks while a pull request, and also enable us to do some releases on the source code. So we focused on two aspects here. One was on pull request, and another was the tag release. So as a contributor creates a pull request, the CI services will trigger a pull request pipeline. A pull request pipeline will run some status checks, such as PyTest, linting checks, and then also check for the build checks if the whole application can be built into a container image or not. Once this process is done, the checks will return the validation. If the validations are all true, the reviewer can review the source code, and if the reviewer accepts the the new changes, then the new changes can be merged into the source code. Once all the pull requests are merged into the source code and the maintainer decides to release a tag, the tag release pipeline will be triggered from the CI. The tag release pipeline runs a image build task, or based upon the application. If it's an application as a module, then it runs a PyPI release task. Once this task is run, the task based upon the application will either release the image to the PyPI index, or else it creates the container image and passes it to image registry, and then updates that tag into the customized manifest so that it can be deployed into the Kubernetes orchestration, OpenShift. So this is what we focused on, and this is what was the requirement and how we designed it. So let me show you the architecture diagram and explain you through that, and then I'll explain you the implementation from the source code, and then I'll show you some live demo. So this is the architecture which we follow. So on the left side you have the source code from the GitHub repository, and also from some of the GitLab repositories. So both of them triggers some webhooks on pull request or the merge request. So this webhooks triggers to the Tekton pipeline running in our environment. It starts a Tekton pipeline for the pull request run. So the pull request pipeline runs some certain tasks, such as lint checks, unit checks, and syntax checks. So once this task completes, it sends out the results to the status check on GitHub. So these status steps could be based upon the results of the task. If the task has completed successfully, they will send out a true status to the GitHub. And once these status are corrected, as you know, reviewer will review the code and merge, and click on merge, and the new changes will go into the source code. Another aspect was, like I said, was the tag release. On each tag release, the GitHub will send out a webhook to the Tekton pipeline. The Tekton pipeline will start the tag release pipeline. The tag release pipeline has a task called build image. The image will be built, and then there's a delivery task which will deliver that image to the image registry. And as of now, we are using the Red Hat Quay to take them. Let me explain you. Let's dig into some implementation demo. So I'll show you some of the source code, explain you through each component, how it's been designed, and what is the purpose of it, and how they will be how they are part of the whole big pipeline of the CI/CD tool chain. And then I'll show you the live demo, like how it works in actual. So let's go through it. Um, so the whole pipeline is, the application is called AICI. It's been developed based on the Tekton pipelines and the Openshift pipelines, and it is available on GitHub. It is also a GitHub application, so you can download it into your own repository and use it based upon that. So before going into the development of the pipeline, first we have to install the Tekton pipeline and Tekton triggers. There is a setup script in the GitHub repository of the AICI, or else you can use the actual Tekton pipeline repositories to install based upon the instructions. You can just read through them and install the Tekton pipeline and a Tekton trigger. Apart from these two, we also install Tekton dashboard. Tekton dashboard enables you to, it gives you a UI where you can visualize all these pipeline runs. So I have already set it up for today's demo, and let me show you that in an OpenShift environment. I have deployed Tekton dashboard, Tekton pipelines, Tekton triggers. So all this is running. There's a webhook listener, and there's a Tekton webhook listener as well. So once you have done this, we have to, as I said, first we have to design our event trigger listener. So let me show you some source code and let's talk through that. So first is the event listener. As you can see, this is the event listener manifest. So in the event listener manifest, we are concentrating on two components as of now. So one is the event called pull request, and another is called the tag release. So in GitHub, whenever a pull request is triggered, there is an event type added to it. It's called pull request to that payload. So as a pull request is generated into GitHub sends a webhook to the event listener. Event listener listens to that, takes the JSON payload and passes that to GitHub trigger bindings. So trigger bindings can be defined as this. And once the trigger bindings have been passed, the trigger bindings takes out the important information from the JSON payload. The JSON payload takes that information. From the JSON payload, the trigger binding takes the information such as event actions, PR, pull request number, the repository to which pull request was raised, repository full name, pull request URL, and repo URL. All this information is then passed to the Tekton trigger template. Tekton trigger template is a resource template which basically runs a Tekton pipeline run. So it describes all the parameters which are passed through the Tekton trigger binding, and then pass those trigger bindings to resource template. Those resource template is a pipeline run in this case. So the pipeline run takes all this environment and it passes this information to a pipeline. Here the pipeline is described as Thoth-CI pipeline. That's the name we have given here, and it has, when we have provided all the parameters. With all these parameters, along with all these parameters, we also pass some resources. These are the pipeline resources which we can describe in an additional manifest file, or we can also describe them in inline. So here some of the resources are being described in inline with the resource spec. The resource spec defines that you're describing inline. You're saying that this type of resource is a git type. You're using the repository URL. So based upon this, it will clone the repository, whichever repository URL is passed to this. So this URL is a parameter. This parameter comes from the JSON payload, as we know. So as one pull request has been triggered, the whole value travels from the event listener, JSON payload, trigger binding, trigger template, and to this resource. Apart from this, you can, as I said, you can describe the resources into a manifest file. Here you see there's a S2I Thoth image, UBI 8 image. We have taken a reference, so these are being described in the resource file. So let's look through them. So here we have described the S2I Thoth image. So the image which we are using is the S2I Thoth base image, which is developed by the Thoth project team. And then there is a UBI 8 image. So we are passing those images as also resources which can be used in Tekton task. And then the pull request itself. So there's a pull request type pull request in this. If we provide the URL, it captures the pull request information into a JSON which is available for each task. One thing to remember here is that each pull request from a public repository can be pulled directly, but from a private repository to be pulled, a pull request to be pulled from a private repository requires some secrets. So authentication secrets. So you can provide that authentication token, the SSH keys, through the secret to directly to the resource. As we have gone through the trigger template and pipeline run, now we know that once this trigger template is triggered, this pipeline would be run. So let's go through the pipeline. The pipeline describes in the spec, we describe the parameter and the resources which we have gathered from the pipeline run. And then we describe some task references. So all these task references each task references corresponds to a task run here. So let's look through one task run. So there's one task run which is a pre-commit check. In this task run, we are describing that this is the task which we need to run. While you're doing that, we want to do some pre-checks before the task is run. As in Tekton, what happens is if you run a task and if the task fails, the whole pipeline fails. There could be some steps in which the task can result into failure, right? So before doing that, it would be better if we do some condition checks. For that, Tekton provides something called Tekton conditions. So Tekton conditions, pipeline conditions, are also a subtask, but their failure doesn't result into pipeline failure. Their failure just results into check failure. So we are just checking if the actual pull request has an action open. If it's closed, we don't want to run these checks. We are also checking some other components, and once it's done, if these conditions are true, then only the pipeline will run. Also, all pipeline will also assert this task will be run. The task will consider some of the parameters and the resources from the pipeline, and run after basically states that unless this task have been run, please do not run the pre-commit check. So as we learned about the task run, let's go through the task, the pre-commit check task. So in the task, we have described the parameters which we gathered from the pipeline, resources which we get from the pipeline. Now we are describing the steps. The first step is taking the information from the pull request and gathering all the information or the changes which were created in the pull request. So we got that changes from the pull request, we checked out a branch, and now we are running some tests on it. We already have a base image for this task. The pre-commit checks are basically series of checks like my checks, Python PyTest checks, Flake8 checks, Pep8 checks. So all these are already containerized into an image, and we would use this image in the step to run a simple script which is pre-commit check run on all files. So we are running this pre-commit check on the all files in that pull request. So the changes have been checked, and once the checks have been run, we update the pull request with information as a status run. We are saying if it was a successful check or not. Once it's done, the pipeline completes. And let's look through this pipeline in a live execution. So let's go to the GitHub. I have set up a GitHub repository for today's demonstration. I have already opened a pull request with some changes to the repository. I made a single change that I've added a print statement into my app.py stating that I'm very excited to present in DevCon 2020. So when the pull request started running, there was the CI/CD system started running. With the CI/CD system running, it did two checks. One is build check and a pre-commit check. As we see, the pre-commit check has failed because there was some issues with the PyDoc, but the build check has finished. So let's see how this results into a Tekton pipeline, right? So in the Tekton dashboard, you can go to the pipeline run. In the section of AICE pipeline run, we see the bunch of tests running. We see the pre-commit check running. As we can see, first it gathered the pull request information. Okay, so let me explain to you first what happened. There was a webhook which triggered the event listener. The event listener triggered the trigger binding, and the trigger binding relayed that to trigger template. The trigger template started a pipeline run. The pipeline run is called AICE pipeline run. This has started the pipeline, which had series of task runs. The task runs have started to execute. Now we are investigating on one task. The one task was pre-commit check run. There was one step to gather the information from the pull request. We gathered some information from the pull request. We run some tests. While the task completed, we send those information through a webhook again to GitHub. As you can see, the step was failed. So we returned a failure, and you can see it's a failure here. And now similarly, we have a tag release pipeline. So the tag release pipeline, on each creation, it takes some of the information like version of the tag, what type of tag is it, and name of the URL. Similarly, it's passing to a tag template. It runs its own pipeline. It's called tag release pipeline. Let's go to the tag release pipeline. In the tag release pipeline, it's basically checking what configurations do you have. Should I build it to release into PyPI, or should I build to make it as a container image? So let's go and see what happens when you are building it to a container image. You're gathering all this information. First is to check if it can be pushed to an image stream or not, image registry. Yes, we can push it to image registry. So we gather the information of a task. In the next step, we take a S2I build. We are building with the information. As you can see, I've added a script which checks if it needs to be built with a Docker file, S2I from a source to image, or from a Docker or from a container file. Based upon the application, if you see here from the source code, it is considered containing a Docker file. So this Tekton pipeline of task release should run the Docker file. And as we can see, it's gathered the Docker file information, and it has built based upon the Docker file. So if you consider the changes in the Docker file, it's basically takes Python 3.6 CentOS 7, it adds the output file, and there's a command. So it has taken the Python 3.6 CentOS file, taken the app, and then and containerized that into image. And now this image is pushed to a query repository. We have pushed the query repository from the second step. So once we have built, we have pushed it. So while pushing it, we also provide the configuration for it to push it to a query repository. As this step is executed, the image is pushed to the query repository, as you can see here. So this is how the whole Tekton pipeline executes. Let us go back to the demo. Let us go back to the presentation. I hope you understood how the pipeline works. There were some few challenges while designing all this implementation. First, as I explained, while interacting, the CI/CD needs to know how to interact with private repositories. I showed you how you can set up a secret and attach that to the SSH connection. Another challenge was that you need to pass one result to another task. There's a Tekton result resource which you can read up on the Tekton pipeline README, and you can use that to store results and pass those as a parameter. Use that to store the results into a file, and then use this file to those resources to use as a parameter to pass them to the next task. Apart from this, there is some of the steps which you need to follow while maintaining the connection between running pipelines and a GitHub status. So while you're doing that, when you're executing a step, you can always pass those information to GitHub as a status check. As I showed you, it shows you if a pipeline task has failed or not. So these were the few common challenges which we faced, and we figured out a way around through them, and we worked to overcome them. Next, let me tell you some of the insights while developing it. We realized that all these Tekton pipelines can be directly plugged into other CI tools like Prof. So you don't need to run it as an individual CI. If you want, you can add it into your pre-existing CI pipeline. If you have something like Prof, which is also a Kubernetes-based CI tool. We also figured out that you can also add this, which also works. The CI/CD system works very well along with additional CI tools such as Zool or Argo, which can be used for gating, and then you can use the CI/CD systems to run some checks. They work in very well with the synergy, because all of them uses YAML arguments and manifest files, so they work very well together. Where one of the biggest thing which we looked into was, like, while developing, we were using OpenShift 3.11, and we realized that Tekton pipeline version 10.2 was the last version which supported that version. So please be careful while you're developing to check which Tekton pipeline matches which Kubernetes version, and if you can implement that in your OpenShift or not. While deploying your cluster, your Tekton pipelines onto the cluster, you need admin privileges. So these are some things which you need to keep in mind while deploying and developing such tools. Hope all this information helps you to build a CI/CD tool. And if you need more information, you can I've added some of the references here. The first two references are of the application which we developed. I have added some of the readmes. Maybe I haven't gone through each and every detail. I wanted to just cover a lot of topics in this short duration. So a few of the topics, a few of the things you can check through from the readme. If you have more questions, you can open an issue over there. If you want to contribute, please feel free to contribute. If you would like others to contribute to this project. Apart from this, I have also added some of the references from the upstream community Tekton, and also the OpenShift pipeline. OpenShift pipeline is the downstream of the Tekton pipeline, which is currently being contributed by Red Hat contributors. So please feel free to have a look at it as well. Thank you so much for attending my talk. I hope you learned a little bit about how to develop a CI/CD with based on a Kubernetes style. If you have more questions, please you can reach out to me on the following links. And for more information about Thoth, I have also provided some links about that. You can reach out to them. Thank you so much. Have a really good day in the DevConf while looking through all the DevConf presentations. Thank you. Stay safe.